So what do you think 5.2 is? It is. What else is it?
Our last one.
It is our last section of new material. It really is. Like, can you believe it? We're almost done with this course. So hopefully in this particular section we'll be getting finished with the multiplication part. That's what I'd like to see us do. So we're going to give it a go. So just like when we did addition and subtraction, we're looking at different models in this section. So the first model we're going to do is the chip model for integer multiplication. Everybody good? Okay, so chips. You know what we do with chips. I've got my blacks and my reds, right? Black dots, red dots for my chips. But what do I do when it's multiplication? Because this says -4 times -3. And it's sort of like okay that one of these is like negative chips. And I don't care even which one you pick. But pick one of them and decide that you've got 4 negative chips. Okay, pick one. If you want it to be 3 negative chips, that's fine. Whichever one you didn't pick, that one tells you what you're either adding in if it's addition or removing out if it's subtraction. So this is telling me now that I'm removing, and it's not removing 3 because that would just be -3, and this is multiplication. This is removing 3 groups. I didn't mean removing. I totally lied. That was my division one. Got it. Hang on just a second. The 3 is 3 groups. No, I had it right. Oh my goodness. I'm so sorry. Now you guys get to write it back in. Removing 3 groups. There we go. Removing 3 groups of 4 negative chips. That's what that's saying. Okay? Or you can say removing 4 groups of 3 negative chips. I don't care. So here's the deal. Write this down because this is really important. Our model is going to start with 0 in the circle. So to start with, I have a circle with nothing in it. So what's the value of my circle? 0, because there's nothing in it, right? Yeah. 0 in my circle. And I need to remove 3 groups of 4 negative chips. Well, I don't have anything in my circle to remove. But we had this happen in the last section, right? When there's not something in the circle that I need to remove, what did I do? Yeah, I put in 0 pairs. So I'm going to put in 0 pairs here. And I need a lot of them. And if you get too many, that's okay. But do you know how many I need? Somebody's right, said 12. How do you know it's 12? Yeah, because 4 times 3 is 12. So I'm going to put in there the 12 of them. If you didn't know this number, my child would have encountered regular multiplication, not regular, whole number multiplication before that, so they would also know that 4 times 3 is 12. That's not a surprise. But what I'm trying to do for my circle now is to remove 3 groups of 4 negative chips. So here is one group of 4 negative chips. Bam. Here's another group of 4 negative chips. And then because I did not, draw them very well, my other one is a wonky group, but that's okay. I still have 4 negative chips that I'm removing. And then I end up with a circle that has what in it? 12 positive chips. Because I've removed the 12 negatives. The charge field model feels the same way, so let's give it a go. Maybe it'll help us to feel more comfortable with the first one. I'm doing the same thing. We'll do it the other way this time just for fun. This one's going to remove 4 groups. Of 3 negative chips. And again, we start with 0. And in order to have things to remove, we have to put in pairs of things. So there are my pairs, like that. And I'm going to remove 4 groups of 3 negatives just for this. Oh, I just did a dot diagram for you, didn't I? Okay, well, let me just show you it works, and then I'll do my charge fields one. My bad. I got so carried away with the fact that I was wanting to show you that removing would do the same thing. Okay, so removing gives you, of course, the same 12 chips. So this one should have looked like losses and minuses. All right, 1, 2, 3, 4, 5, 6. Okay, I think I got them all in there. And again, I'm removing 4 groups of 3 negatives. So here's a group of 3. Here's a group of 3. Here is a group of 3. And here is a group of 3. And when I'm done with the charge field model that I finally drew, what do I have left? 12 positives. 12 positive chips. Okay, ready for number line model? All right, so again, we've got to provide context for what negatives mean with this. So let me write them down first. I'm going to be real careful so that I don't mess this up. This is to move. This tells us we're moving left because it's negative. If it were positive, we would be moving right. Move left 4 at a time. And the other negative tells you when you started. So this is at a time starting. And I'm going to use the word hours. There's nothing special about hours, but I need a time reference. So starting 3 hours ago. And I think if I draw the picture, it'll start to make more sense. So before you ask me questions, let me draw it. So I don't really need to worry about starting or ending anywhere. I'm just going to put a mark on my graph. And I'm going to skip count 4 to the left. So, and I'm going to do it 3 times. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And I actually need to end at 0. So in this model, whatever's going on is I end at 0. Kind of like with my chips in my charge fields model, I start with 0 in the circle. Here I need to end with 0. And the answer to my question, which happens to be 12, of course, is where did I start? And a context question makes this sound more reasonable. There's a really good one that's in your group work when we get to this section of group work on Monday, and it talks about this something like this. A university is losing enrollment by 50 students per year. How many students did it have 5 years ago? It had 250 more students, something like that, right? So it's looking at the past of what happened in the past. Where did it begin? How many have now been lost? Okay. Integer multiplication, a couple of little facts here at the bottom. And then I think we can stop for today and do group work after this page. So let's do one more slide and then we'll pause. A and B are integers. If A is negative, right, less than 0, and B is less than 0, then A times B is equal to the absolute value of A times the absolute value of B, if they're both negative. The second line says, well, what if they're not? What if one of them's positive and one of them's negative? And it doesn't matter which is which. That's why there's 2 conditions here. This one says A is negative, B is positive. This one says A is positive, B is negative. Okay, if I have one of them positive, what does that mean instead? Well, it means that A times B is actually equal to the negative absolute value of A, absolute value of B. So this is telling you if I have two negatives and I multiply, I get a positive. If I have one negative and the other positive and I multiply, it stays negative. And there's other ways, of course, that this could be written down. This is simply the way your book chooses to write it, okay? All right, so we'll stop here. We'll pick up with section 5.2 on Monday.